Okay, yesterday we talked about parallelograms, and those are shapes with four sides, so quadrilaterals, where the opposite sides are congruent and parallel. That's sort of the main thing. Today we're going to talk about rectangles, and I know you've heard of rectangles before and you know what they are. We're going to talk about some of the relationships inside of rectangles that maybe you haven't thought about before. Before we do that, I want to review a couple of concepts that we had in the fall. The first one, alternate interior angles. And so there's sort of two parts. There's the alternate part and the interior part. The interior part means that it's somewhere in between these two parallel lines. The alternate part means that the two angles I'm talking about are going to be on opposite sides of the transversal. So alternate interior angles are angles that are on opposite sides of the transversal, right? This one's kind of above or to the left of the transversal. This one's to the right or below, but they're both within the two parallel lines. So alternate interior angles. The thing that's important to know about alternate interior angles is that they are congruent. So whatever this angle is right here, it's going to be congruent to this angle right here. I could draw two different alternate interior angles here. I could also say that this angle and this angle are congruent because they are alternate interior angles. Those two blue angles on opposite sides of the transversal, but both are within the two parallel lines. All right, the other thing I want to review is what an isosceles triangle is. Isosceles triangles are triangles that have two sides that are congruent, and we call those the legs. And then the third side, whatever the third side is that is not necessarily congruent to the other two, we call that the base. And along the base, there are two angles that are congruent. So isosceles triangles have two sides that are congruent and two angles that are congruent. So for this triangle here, A to B is going to be congruent to AC, and then angle C is congruent to angle B. The base is not necessarily congruent to either of the other two sides, but it can be. And then same thing over here, I could have another isosceles triangle. Doesn't have to be the base on the bottom. The base just means it's the side that's not necessarily congruent to the other two. All right, rectangles. Again, I know you've already heard of rectangles. I know you know what a rectangle is. What we're doing now is we're going to think a little bit about what's happening inside of a rectangle. Okay, so like I said before, a rectangle is a parallelogram. So let's start there. What that means is, like we talked about yesterday, opposite sides are parallel. All right, so AB is parallel to DC, and then BC is parallel to AD. Opposite sides are also congruent. So AB is congruent to DC, and BC is congruent to AD. So that's because rectangles are parallelograms. The other thing we talked about yesterday with parallelograms is that they're diagonals. Their diagonals bisect each other. In other words, these two gray lines that I've drawn connecting opposite corners cut each other in half, right? So that and that are equal to each other. We've cut that DB into two equal parts. And we've cut AC into two equal parts. We've bisected them. Okay, rectangles are a little bit, they're special types of parallelograms. What's different about a rectangle is all four angles are 90 degrees. All four angles are right angles or 90-degree angles. The other thing is diagonals are congruent. Right? They don't just bisect each other, but they're also congruent. In other words, AC is congruent to BD. What that also means then is that these two segments that we have when we bisect both of the diagonals are all four congruent. So all four of these little line segments inside the rectangle are going to be equal to each other. The last thing that's kind of unique about rectangles, is that these four triangles that I've created inside of them are all going to be isosceles triangles. So for example, if I just look at this one right here, it's an isosceles triangle. The way that I know that, I have two congruent sides, a third side that may or may not be congruent, and then what that's going to mean is that these two base angles are also going to be congruent. It's the same thing on the other side. This triangle right here is going to be isosceles for the same reason. And then this triangle and its opposite is also isosceles. Okay, problems with rectangles. These first two are pretty easy. I just want to make sure that you guys understand what we did on the last slide enough to get into the problems. All I'm asking you here is, are these two shapes rectangles? Okay, so on this first one, the one on the left, the only information I have is that I have two right angles, and then I have a 91-degree angle and an 89-degree angle. So is this a rectangle? Well, the answer, hopefully you could tell, is no. Why isn't it a rectangle? Well, because rectangles have all four angles at 90 degrees. And that's not the case here, so that one is not a rectangle. For the one on the left, is it a rectangle? Well, the only information I know, AC, so one of the diagonals is 10, and then DB or BD, the other diagonal, is also 10. This one is a rectangle, right? If diagonals are congruent in a quadrilateral, we have a rectangle. Next problem. It says quadrilateral WXYZ is a rectangle. Okay, so the reason it tells us that, I mean, we can sort of look at the shape and see that it's a rectangle, but when it tells us that, what we know is that opposite sides are going to be congruent and parallel. And then we're also going to know things like the diagonals are congruent and all four angles have to be 90 degrees. Let's see what the problem's actually asking for. So it says ZY. So z to y is 2x plus 3. And then it says wx, so wx down here is x plus 4. And it wants us to find wx. So the answer that I get eventually needs to be, how long is wx? What I know is that when I have a rectangle, or any parallelogram really, opposite sides are congruent. So in other words, zy has to be congruent to wx. If I use substitution, then I can just say 2x plus 3 equals x plus 4, and then I'm going to have an equation to solve. So I'm going to subtract 3 from both sides. 2x is equal to x plus 1. Subtract x from both sides, and x ends up being just equal to 1. Okay, but it doesn't want to know x, it wants to know what wx is. Wx is equal to x plus 4. That's just this right here. If I know x, I can substitute that in. So instead of writing x plus 4, I can write 1 plus 4, right? I know x is 1, so I can put a 1 right there. And then 1 plus 4 is 5. So I know wx is equal to 5. There's my answer. Next problem. If measure of angle ZYW equals 2x minus 7, so I'm going to stop there. Angle ZYW. So before I go any further, I'm going to mark off which angle that's talking about. If these are the two sides of the angle, then there's the angle right there that I'm talking about, and it says that is equal to 2x minus 7. It's saying if that's 2x minus 7, and then the measure of angle WYX, so WYX, there's one side of that angle and the other side right here. So here's the angle I'm talking about now. That one's going to be equal to 2x plus 5. It wants us to find, in other words, say the measure of angle ZYW. All right, so before I can do that, I have to figure out what x is. it's going to be pretty easy. It's tempting to think, well, we just set 2x minus 7 equal to 2x plus 5, but that's not what we're going to do here because those two angles are not necessarily congruent. In fact, they're not congruent. What I do know about them, because they're in the corner of a rectangle, those two angles put together have to add up to 90 degrees, right? Because all four angles inside of a rectangle are right angles. So I know that ZYW and WYX, if I put those two together, I'm going to get 90 degrees, right? Angle ZYW plus angle WYX. If I put those two together, I'm going to get 90. So now I'm going to use substitution. ZYW is just 2x minus 7 plus WYX is 2x plus 5. Now I'm going to combine like terms. I have 2x and 2x. And then I have negative 7 plus 5 is negative 2. And those things added together equal 90. Add 2 to both sides. 4x equals 92. Divide both sides by 4. And x comes out to be 23. Okay, but it doesn't want me to stop there. It doesn't want to know what x is. It wants to know the measure of angle ZYW. So to figure that out, I'm going to use substitution again. I know that angle ZYW is equal to 2x minus 7. So I'm going to substitute in this 23 for x. So instead of 2x, I have 2 times 23 minus 7. 2 times 23 is 46. Minus 7 is 39. So the measure of angle ZYW is going to be 39 degrees. All right, this problem is a little bit more complicated, so it's going to take a little bit more time to explain. Please try to bear with me, though. What we have here are these 4 coordinates, these 4 points, G, H, J, and K. And I've already plotted them to save a little bit of time. But it wants me to use the slope formula, which is this. To figure out whether this shape that I've drawn is a rectangle or not. And it sort of looks like it might be, but we have to be kind of strict here. We can't say yes or no just by looking at it. We have to think back to what things have to have in order to be a rectangle before we can answer this question. So 2 things I know for sure about rectangles are that opposite sides are parallel. And another thing I know is that every corner of the rectangle is a right angle. Okay? So 2 things. If I want to see if this is a rectangle or not, I have to do 2 things. One is HG parallel to JK, right? Are the top and bottom sides parallel? 2 is HJ parallel to GK. And the third thing I need to figure out is GK perpendicular to JK? Okay, why do I want to know if GK is perpendicular to JK? Well, lines that are perpendicular meet at a right angle. And so if I can find that one of the places where the 2 sides meet is perpendicular, in other words, is a right angle, then that tells me that all 4 are going to be right angles. So I only have to do that once. Okay, so to answer this question, I'm going to have to do it in 3 steps. What I need to do is figure out whether all 3 of these things are true. If they are, I have a rectangle. But if even one of these things is not true, then I don't have a rectangle. All right, slope formula. It's where I plug in the coordinates to figure out what the slope of a line is. So I need to know if HG is parallel to JK. Okay, so I'm going to take HG, I'm going to solve for its slope. H is at negative 7, 7. G is at 1, 8. So what I like to do is, there's my first x, there's my first y, here's my second x and second y. Figure out the slope of hg. Now I just use this formula up here and I plug in the numbers where they belong. So my y2 is 8, y1 is 7, x2 is 1, x1 negative 7. So hg is going to be 8 minus 7 is 1 over 1 minus negative 7. Well, that turns into a plus. So slope of hg is going to be 1/8. Now I have to figure out if that slope of hg is the same as the slope of jk. So I'm going to do the same thing for jk. J is at negative 6, 1. K is at 2, 2. So x1, y1, x2, y2. 2 minus 1 over 2 minus negative 6. 2 minus 1 is 1. 2 minus negative 6 turns out to be 2 plus 6, which is 8. All right, so to answer our question about this one, yes, this is true. HG is parallel to JK. Okay, so I'm like 1/3 of the way done with the problem. Now I have to figure out if HJ is parallel to GK. Okay, so I could use the formula again, or I can sort of, since I have it pictured here, I can sort of cheat a little bit. I'm just going to look and see what the slope of HJ is. HJ. So the slope is rise over run. In other words, how far up or down do I go over how far to the right do I go? Well, if I'm looking at HJ, to get from H to J, what do I have to do? Well, I have to go down 1, 2, 3, 4, 5, 6, down 6, and then I have to just go over 1. So the slope of HJ is just negative 6 divided by 1, which is negative 6. I can do the same thing for GK. Slope of GK. What do I have to do to get from G to K? Go down 1, 2, 3, 4, 5, 6. And once again, over 1. So the slope of GK is also going to be negative 6. So far I'm 2 for 2. HJ and GK have the same slope. Okay. So if I can show that GK is perpendicular to JK, then I have a rectangle here. But all I've shown so far is that I have a parallelogram, not necessarily a rectangle though, right? Because for this to be a rectangle, I'm trying to show that this is a right angle right here. In other words, is GK perpendicular to JK? Perpendicular lines have slopes that are negative reciprocals. And the way I'm going to figure that out is I'm going to look at the two slopes. So GK, I just found, has a slope of negative 6. So can I flip that and change its sign and have it be 1/8? Let's see. If I flip it, well, it starts out as negative 6 over 1. If I flip it, it becomes negative 1 over 6. And then if I change its sign, it just goes to 1/6. Because 1/6 is not equal to 1/8, and again, I'm getting the 1/8 from over here, these are not perpendicular lines. In other words, GK is not perpendicular to JK, and so I do not have a rectangle here. All right, last problem with rectangles. This one wants me to figure out whether a quadrilateral with these coordinates, which I've already put in here for you, is a rectangle or not. And again, it sort of looks like it, but we can't be sure, right? The last one looked like a rectangle, but it turned out it wasn't. This time, though, it wants us to use not the slope formula, but the distance formula. And when it says distance formula, what we're really doing is using the Pythagorean theorem. And that's the thing where we look at 2 points and we make a triangle, and then we do the a squared plus b squared equals c squared thing. Okay. Well, how could we use a distance formula to figure out if this shape is a rectangle or not? Well, the only two of the things that have to be congruent for a quadrilateral to be a rectangle are its diagonals, right? The opposite sides have to be equal, but that doesn't necessarily tell me for sure whether it's a rectangle or not, right? What will tell me for sure that it's a rectangle is if these two diagonals are congruent. Right? If those two lines that I just drew in gray are congruent, are equal to each other in length, then we have a rectangle. Okay, well, how are we going to do that? Well, again, like I said, the Pythagorean theorem is this thing. To use this formula, we have to create a triangle. So I'm going to do TR first. Figure out the distance from TR. I'm going to make that the hypotenuse. Right? That's going to be C. And then I'm going to finish the triangle by drawing a line down from T and over from R. It's got to be a right triangle, which it is here. And then I'm going to call that side A and this side B. Right? So how long is A? 1, 2, 3, 4. So C squared is going to be equal to 4 squared plus, how long is B? 1, 2, 3, 4, 5, 6, 7. 4 squared plus 7 squared. And so if I go through and simplify, 4 squared is 16, 7 squared is 49. So C squared is equal to 16 plus 49. C squared is equal to 65. But I don't want to know what C squared is, I want to know what C is. So at this point, I have to take the square root of both sides. The square root of C squared is C. And I'll just leave the square root of 65 how it is. So TR, which I called C when I was using the formula, TR is equal to the square root of 65. All right. So the only way this is a rectangle is if the distance from Q to S is also equal to the square root of 65. What I'm going to do, I'm going to erase this orange triangle that I drew to figure out TR. I'm going to draw a new orange triangle, this time for QS. All right, so I want a triangle where this is the hypotenuse, and then I have these two sides. So I'll call this one B, I'll call this one over here A. Again, this one is for QS. C squared equals, what is my A? A is just 1 in this case. So 1 squared plus, what is B? 1, 2, 3, 4, 5, 6, 7, 8. Okay. C squared equals 1 squared. Well, 1 squared is just 1. 1 times 1 is 1. 8 squared, 8 times 8 is 64. So C squared equals 1 plus 64, which is 65. Got to take the square root of both sides again. And you can probably see what's coming. C is equal to the square root of 65. C in this case, the C was Q to S. So QS is also equal to the square root of 65. Both of the diagonals in this shape are congruent. So yes, this is a rectangle.